All right, in this video, we're going to go over AP Practice Problem 13. This is a pretty good probability problem. It's got a good range from easy to difficult probability questions. So to remind you of the scenario, it's basically about women's tennis. In women's tennis, in order to win the match, that's sort of the whole point, to be the winner, you have to play a certain number of games, and then a certain number of games make a set, and a certain number of sets make a match. So they just keep it simple. They go, in order to win the match, you have to win 2 out of 3 sets. If you know anything about tennis, for men it's 3 out of 5. For women it's 2 out of 3. So basically, if a woman wins 2 out of the 3 sets, she wins the match. And they basically give the scenario that, if you win the first 2, you don't have to play the third one. But clearly, if there's one winner the first time and then a different winner the second time, they play the third one to sort of tip off which way it goes. All right. So basically, most people know how 2 out of 3 works. It's a 2 out of 3 win situation. So part A here is not too difficult because they basically want you to draw out the scenarios. First, that for part A, what are the scenarios where player V wins? And make sure you use their letters. They said let V represent a win by player V and an M represent a win by player M. Makes sense. So they want to know what would the sequence be where player V would win the match, and then what are all the sequences where player M would win the match. So basically, what are all the scenarios? So let's start with player V. If you're player V, the first scenario is that you just sweep. You win the first 2 matches and it's over. That'd be nice. Player V could have also scenario 2 where they win the first one, then they lose the second one, and then they get the victory in the next one. So basically it's tied, and then they win that second one, so they win the whole match. The third scenario is sort of the upset situation for when they upset M. M wins, then V wins, and then V wins the second one. So since V won 2 out of 3, once again, they win the whole set. So basically, if V's going to win the whole match. If V's going to win the match, this is the only 3 ways that it can happen. Then they want the same for M. What are all the ways M could win? It's basically just changing the V's to M's and M's to V's, right? If M wants to win, M could just sweep. M could win the first one and then tie in the second and then win the third. Or, once again, M could upset V. V could win the first one, and then M could sweep the rest of them, and then that would result in 2 out of 3. So basically, these 2 aren't too bad. Just make sure you use V and M because that's how they define it, right? But these are all the scenarios. Basically, this is everything that could happen if you put them both together, right? These are all the scenarios. So that one's not so bad. The next one gets more difficult. I did it by a tree diagram. That way I could set up the correct multiplications. You don't have to do the tree, but I'm going to explain it that way. So basically, they use historical data. V and M play each other a lot, and they have enough data to know the probabilities of the likelihood V or M will win given certain scenarios, right? So they give us all these things. Let's make sure we understand them. It says if player V wins the first set, the probability she'll win the second set is 0.6. And I think it says they have equal probability of winning the first set, right? Yeah, I should skip that part. They're equally likely to win the first set. So basically, in the first set, there's half a chance V wins and then half a chance M wins. That makes up what couldn't happen, right? So it's 50-50. And then what I had just said, that the probability that V will win the second set, so if V's a little more likely to win if she wins the first one, she now goes up to 0.6. So that puts M at 0.4. And then it says if player V loses the first set, the probability she loses the second set goes up. So basically, if V loses, she's more likely to lose the second time. So that makes M able to win at 0.7. V would win at a rate of 0.3. So now I have to go one more branch because, in these scenarios, there's got to be one more game. So then they say if V wins exactly one of the first 2 sets, the probability she wins the third is 0.45. So basically, if she wins 1 and loses, or here loses 1 and wins, she has an equal probability of going on and winning the third set, which is a little under 50%. So she's a little less likely than M to win at that point. Now that I have the tree all drawn out, so I didn't they don't really ask about M, so M would be 0.55 or Yeah, 0.55 and 0.55 for the branches. So now they go, what is the probability player V will win a match against player M? Well, we have these three scenarios. I need to find the probability VV, VMV, and MVV. I can do that once I set up this nice tree. It's easy to get because I just multiply. What's the chance of V and another V? Well, it's 0.5 times 0.6. So overall, this will happen 0.3 or 30% of the time. What's the chance of VMV? Well, 0.5, 0.4, and then 0.45. Put all that together, and there's a 9% chance of that happening. And then the other way V will win will be M and then a double V. So it's 0.5, 0.3, and 0.45. Multiply all them together. Got my parentheses. And that comes out at 0.0675 or 6.75%. So those are all the scenarios that V wins and how likely they are to happen. So notice that different scenarios aren't, like, it's way more likely the double V happens than a mixed win, all right? But basically, what's the chance V wins? Well, these are all exclusive events, so we'll just combine them together. And the total chance, like, what is the chance V wins against M? Well, overall, it's a 45.75% chance, or 0.4575, all right? So it looks like M's a little bit better of a player overall against V, but not too bad, right? Okay, so that is how you can figure out the probability that V is going to win a match overall. Then they ask a given probability, which you have to remember the given probability. Well, let's read it. They go, what's the probability that a match between player V and player M will consist of 3 sets given that player V wins the match, right? So there's 2 scenarios that fit this out of 3 possible scenarios, right? So what they're basically asking for is given probability. What's the probability it takes three sets of, given that V wins, right? So the chance that V wins is this. So this is sort of our total set of events, right? We're going to ignore when M wins the match. So what's the probability V wins? This is the chance that V wins. How many of them are 3 set scenarios? Well, it's these 2 things, right? 2 of these scenarios are 3 set matches. This is how often they happen. So when you do given probability, I need the total, I need the total probability V wins out of the scenarios that are both, that are V winning with 3 sets. So that includes these 2. So basically, I need the probability that V wins and it's a 3-set win out of all the ways V can win. So basically, all the ways V can win is this total that we just came up with, 0.4575. And then of those, which ones are the 3-win ones? Well, it's just these 2 put together. So I'm putting these 2 together out of the total of all 3 of them. So basically, this is getting excluded. So that happens, these 2 things happen 15.75% of the time out of the total 45.75% of the time V would win. Divide those 2 numbers. And so given V wins, what's the chance it's a 3-set win? Well, that happens 0.344, about 34.4% of the time. So that one's a little tricky because you have to remember how to do given probability. But if you remember, it's actually not that difficult. Basically, all the information's up here. It's these 2 out of this. Last question. What is the expected number of sets played when V competes in a match against player M? All right. So basically, the minimum number of sets is 2. The maximum number is 3. If they did this over and over and over and over and over and over and over again, just kept playing on average, what would the average number of sets played be? It should be between 2 and 3 somewhere. So let's see how we figure this out. Well, first we need how often a 2-set match happens. Now, we do have to consider all scenarios, that is V winning and M winning, because we haven't really been talking about M winning, but now we need to figure that out. So basically, how often will the match result in only 2 sets? Well, it'll be when V wins, when V sweeps, or when M sweeps. V sweeps, we already know this from before, 30% of the time. So 30% of the scenarios are this. How often does M sweep, well, I can go back to my tree diagram and multiply these together, and that actually happens 35% of the time. So there's a two-set match 65% of the time. So 65% of the time they play, it's only two sets. I could go calculate the other ones, but I don't have to, because basically the leftover, the only other possibility is a three-set match. Well, if they do two sets 65% of the time, one minus that 35% of the time are the three sets. Well, now that I have how often they happen, I basically need to find the expected value. I need to weigh them by their value. So I get two 65% of the time, three 35% of the time. If I multiply 2 by this number and 3 by this number, add them together, it weighs it out. So remember, that's the expected value of a probability distribution. The way that gets calculated is you take the value times its probability, the value times its probability, and if there are more of them, you keep doing that and add them all up, and it would give you the average. So on average, here's the expected value. Well, I get two sets 65% of the time, three sets 35% of the time. Multiply these together, I get 1.3 and 1.05, and then add them together. This is the expected value. So if they did this over the long run, did lots and lots and lots and lots of matches, and you averaged it all up, on average they would play 2.35 sets. And like I said, it makes sense because it's greater than 2, less than 3, and it's actually weighed more toward, like, it's more often that they only play 2 sets. So on average they play 2.35 sets. All right? A pretty good probability question, as I said. Something like this is a bit harder unless you go back and look it up or you remember it. This can be a little tough, but I think certain problems here, this is definitely a gimme. This isn't so bad either if you have a strategy for it. So hopefully this reminds you of all those things. All right, let's look at the grading, and then this is the last problem. So hopefully this will be enough to get you some, at least a pass on your test, right? Because most of these problems were flagged by the AP people. Part A. So part A was just doing the M's and V's. Basically, an E if you were correct. P is if all, it's kind of weird. This rarely happens. I mean, most people just get this right, or they don't know what they're doing. But the partially correct was all your lists are 3 in length. So you have the correct ones in there, but you made them all 3 in length. So it's kind of a weird thing. Or you have the correct ones and have some other ones in there as well. So they did, if you somehow came up with the correct ones and just had others, they gave you a P. Like I said, this rarely happens. If otherwise is the I, the one way that you don't get any credit on this is if you don't use the letters. Like if you had put X and Y or something, unless you define them, you should use the M's and V's. So that's one way to get an I, and you don't want to do that. B and C were graded together, so it was a little weird because B and C are both kind of complicated, right? There's this tree diagram, or at the very least the multiplications, and then turning it into a given probability. So I feel like it's weird that they lumped this together, but they did. So B and C are lumped together, so you'll get an E, P, or I for the entire section. Basically, part B being correct and part C being correct are two of the criteria. Part B is linked to part A, so you need to somehow use the information part A to get that answer. And then the last one is that conditional probability. So you with the sufficient work, all right? So there's lots of different sections here, but basically they're looking for this number and this number being correct. These haven't been linked from A, and the work that goes along with getting this. So, I mean, this answer could get you a point by itself, but you want to show at least some of this logic in order to get it. All right? So hopefully that makes it clear. Those are the 4 things, the 2 answers, the link, and the work for the second part. All 4 of them get you the E. If you have 2 or 3 of those 4 parts, you get the P. All right. If you don't have at least 2 of them, well, then you don't get anything. Lastly, D, the probability distribution and the expected value are the points. So what do I mean by that? The probability distribution is this. They want to know what's the expected number of sets. Well, there's 2 scenarios, 2 sets and 3 sets. 2 sets happen 65% of the time, 3 sets happens 35% of the time. This is the probability distribution because it shows you of the 2 things that can happen, how often will they occur. All right, so this one occurs more often than this, and probability distribution gives you their probabilities, and it adds up to 1. These are all the scenarios. So this part is basically the probability distribution part, and then the second part, the calculation for the expected value, is this thing. So if you have both of those things, obviously you get the E. If you have 1 out of 2, you get the P. Otherwise, you get the I, and then it's the classic scale for 3 sections. Once again, they could have made this a 4-section one, but they didn't. So 3 E's is a 4. You get 1 part off. You get 3. These are 2 or 3 piece errors. And then these are the weak responses. If you have double P or just an E and nothing else, you get 1 point. And then obviously anything less than this doesn't do anything for you. Okay, so this was a good, like I said, good probability review. It was AP Practice Problem 13. This was the last one assigned. So from here, hopefully you've looked over what you've needed to, and good luck to you on the exam. If you have done all these practice problems and understand what they're looking for, I can't see how you could go wrong on test day. You at least should get 3. If not, maybe you up yourself to a 4 or 5 would be great. All right, well, that ends the set of videos, and like I said, good luck to you.